Today, let's review scientific notation. Instead of writing very big or very small numbers, we use scientific notation. Scientific notation is written in the form of coefficient multiplied by our base 10 to the power of our exponent. C, or our coefficient, will either be greater than or equal to 1, but less than 10, and multiplied by our base, which is always 10, to the power of our exponent, which could either be positive or negative. So if we have 4,500, which is a whole number, and we are going to convert it into scientific notation. As you can see, it does not have a decimal point. Remember that the decimal point of whole numbers are always after the ones digit. So it is right here. So we are going to move the decimal point to the left until there's only one remaining digit to the left of the decimal point. So we have 1, 2, 3. So we are going to stop here because 4 is the only remaining digit to the left of our decimal point. So we have 4.5 times our base, which is always 10, to the power of our exponent will be the number of times we moved our decimal point, which is 3. And since we moved that to the left, our exponent will be positive. So the scientific notation of 4,500 is 4.5 times 10 to the power of 3. And if we have 0.0677, as you can see, we already have our decimal point here. So we are going to move it to the right until we have our first non-zero number. So let us move the digit 1, 2. So we are going to stop here because 6 is our first non-zero number. So we have 6.77 times 10 to the power of, how many times did we move our decimal point? 2. But since we moved it to the right, it is going to be a negative exponent. So the scientific notation of 0.0677 is 6.77 times 10 to the power of negative 2. Now, let's convert scientific notation into standard form. If we have 4.5 times 10 to the power of 3, what do we have? So we have 4.5. And we are going to move the decimal point to the right. How many times? As much as the exponent indicates. So 3 times. So 1, 2, 3. In these spaces, we are going to put 0. So 4.5 times 10 to the power of 3 is equal to 4,500. And if we have 6.77 times 10 to the power of negative 2, what do we get? So we have 6.77. And since our exponent is negative, we are going to move the decimal point to the left. So 1, 2. So again, we are going to put 0 in the space. And we can put 0 before the decimal point. So 6.77 times 10 to the power of negative 2 is equal to 0.0677. Take note that the 0 before the decimal point is not with the exponent. Let us expand and learn more about this through our examples. For our first 5 examples, we are going to convert standard form into scientific notation. For our first example, we have 0.113. So let us move the decimal point to the right until we have its first non-zero digit. So let's move. We're going to stop here. So we have 1.13 times 10 to the power of negative 1. Next, we have 2.5. As you can see, there's only one remaining digit to the left of decimal point. So for our scientific notation, all we have to do is copy the number 2.5 times 10 to the power of. Since we did not move our decimal point, our exponent will be 0. Next, we have 0.004. So let us move our decimal point until we reach its first non-zero digit. So 1, 2, 3. We are going to stop here. So we have 4 times 10 to the power of negative 3. Next, we have 7,008,000,000. So let us move our decimal point from here and after one's digit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 7.8 times 10 to the power of 9. And lastly, we have 0.0000458. Again, let us move our decimal point to the right until we find its first non-zero digit. So 1, 2, 3, 4, 5. We're going to stop here. So you have 4.58 times 10 to the power of negative 5. Now, we are going to convert scientific notation into standard form. First, we have 5.6 times 10 to the power of 7. So, we are going to move the decimal point 7 times to the right. So, we have 5.6. Let us move the decimal point. 1, 2, 3, 4, 5, 6, 7. We are going to put 0 in these spaces. So 5.6 times 10 to the power of 7 is equal to 56 million. Next, we have 2.1 times 10 to the power of 4. We are going to move the decimal point 4 times to the right. So we have 2.1. Let's move the decimal point. 1, 2, 3, 4. We are going to put 0 in these spaces. So 2.1 times 10 to the power of 4 is equal to 21,000. Next, we have 7.8 times 10 to the power of 6. So we are going to move the decimal point 6 times to the right. So we have 7.8. So let us move the decimal point. 1, 2, 3, 4, 5, 6. We're going to put 0 in these spaces. So 7.8 times 10 to the power of 6 is equal to 7,800,000. Next, we have 2.2 times 10 to the power of negative 5. And since our exponent is negative, we are going to move the decimal point 5 times to the left. So we have 2.2. So 1, 2, 3, 4, 5. Put 0 in the spaces. Again, you can put a 0 before the decimal, but it is not counted with the exponent. So 2.2 times 10 to the power of negative 5 is equal to 0.000022. Lastly, we have 1.2 times 10 to the power of negative 8. And since our exponent is negative, we are going to move the decimal 8 times to the right. Let's move the decimal. 1, 2, 3, 4, 5, 6, 7, 8. Put 0 in the spaces. Again, you can put 0 before the decimal point, but it is still not counted with the exponent. So you have 0.000000012 as our standard form for 1.2 times 10 to the power of negative 8. That is all for today. Thank you for watching and see you next time.